welcome to Hydropower. Today we are talking about the optimum number of rain gauges. So in this session today we will discuss about the procedure to obtain the optimum number of rain gauges, and then we'll go to the derivation to calculate the optimum number of rain gauges. So let's start the procedure to obtain the optimum of number of rain gauges. In this, the first step is to calculate step 1 to calculate the optimum number of rain gauges is calculation of mean rainfall. Mean rainfall LIT notation P bar भन्ने गर्छौं. यसको क्याल्कुलेसन फर्मुला चाहिँ P bar equals P1 plus P2 plus P3 plus ... P up to N is divisible by N. P1, P2, P3 means the rainfall at point 1, point 2 and up to point N. It can be noted as I equals 1 to N Pi is divided by N. Then the second step is calculation of standard deviation. Standard deviation sigma P. This can be calculated at sigma P is equal to root of P1 minus P mean whole 2 plus P2 minus P bar whole 2 plus P3 minus P bar whole square up to Pn minus P bar whole square is divided by N. N minus 1. This can be simply written in a simplified form as summation I equals 1 to N times a Pi minus P bar whole bar is divisible by N minus 1 whole root. Now the third step is calculation for the coefficient of variation of VARIA TIO and variation CV. This CV calculation formula is sigma P is divisible by mean into 100%. Now after this, the step fourth is calculation of optimal number of rain gauges with allowed percentage error. Optimal number of rain gauges with allowable percentage error of E, that is N. It can be calculated as N equals CV by error E power whole square E square, and where E is usually taken as 10% is 10% दिने गरिन्छ. And the final stage here, last stage, step 5 is calculation of additional number of additional number of rain gauges required. Additional rain gauge required is equal to capital N minus N. This N comes from the here, and this N is small n is the number of data that we have already provided. Now after this calculation we will go to question Now let's start solving the question related to rain gauge station. Here we have given a question. A catchment area has 7 rain gauge stations in a year. The annual rainfall recorded by the gauge are as follows. The gauge first, second, third, fourth, fifth, sixth and 7 are given, and it's the rainfall recorded in each gauge is given in a centimeter, 130, 142.1, etc. in up to 7 number. Now the further question is, for a 5% error in the estimation of the mean rainfall, calculate the minimum number of additional stations required to be established in the catchment. So let's start solving this question with solution. As we discussed earlier in the derivation, now we start this with the mean rainfall. P bar, which means mean means calculating of this rainfall is divided by number of n, that is 130 plus 142.1 plus 118.2 plus 108.5 plus 165.2 plus 102.1 plus 146.9 is divided by n. N means 1, 2, 3, 4, 5, 6, 7. And its solution, solving this, will get the 130.429 cm. After calculating the mean rainfall, now we'll calculate the standard deviation. In second step, we'll calculate standard deviation sigma, whose formula is pi minus p bar is 2 by n minus 1 whole root is equals to 130 minus 130.429 whole square plus 142.1 minus 130.429 whole square plus 118.2 minus 130.429 whole square plus 0.5 minus 130.429 whole square plus 165.2 minus 130.429 whole square plus 2.1, these points are no, whole square plus 146.9 minus 130.429 whole square is divided by n minus 1, means 7 minus 1 and its whole root. Now on solving this now let's calculate the coefficient of variation. Coefficient of variation C V equals sigma by P into 100%. 100% is equals to sigma is calculated 22.54 and P is already calculated 130.429. 130.429 into 100%, and it's on solving this 22.54 is divided by 130.429 into 100, 100%, it means 17.28%, 17.28%. Yeah, in the question we have given the error in estimation is 5%. From the question, error in estimation equals 5%. Then the optimal number of rain gauge station, optimal number of rain gauge station, n equals 17.28 is divisible by 5 whole square. On solving this, get 11.925. So 17.28 is divided by 5 square, 11.94, 943. We'll say 12 station. Now let's calculate the number of additional station required. Now the number of station required is capital N minus n equals capital N is calculated n, that is 12, and the small n is the previous given data, and it's 7 equals 12 minus 7 is 5. That's the final answer. So this much for today. We'll come again with a new video. Till then, keep on watching our channel and don't forget to subscribe. Thank you.